So we finished this section with an applied problem. So we've got the average temperature per month in a city is given by the following trig function, where temperature is measured in degrees Celsius, and T is the month of the year. So T equals 1 is January, and T equals 12 is December. Now, this is clearly a cyclic function because and periodic, right? Because every January, we should fall back on the same average. So T equals 1 and T equals 1 plus 12, so 13 should roughly have the same value, the same average. Okay, since we're talking about the average, so it's not a surprise that our function is or that this temperature is modeled by a trigonometric function. So let's take a look at it in Desmos. So this is what the function looks like in green, and the dashed lines, the one to the farmost left is T equals 1. So and I just wanted you to notice that if I add 12, so T equals 13, T equals 25, and so on. The intersection point is these points here all have the same. So this one, they all have the same y value, the same average, because we're always in January for those values of T. Okay. Note also there are some months where the average temperature is the largest. Here. Some months where it's the lowest, clearly. And there's some months where it's just some other temperature. So we're going to look at questions where we investigate all those. So even though on the graph it appears the period is 12, like, can we recover that from the formula given to us? So question. So let's say I don't have access to Desmos, and I'd like to know what is the period for this function. Period, remember, it's a length that represent so here a length of time where you've got a full cycle for the function. What is the period of this function? So sine and cosine have a period of 2 pi, but that's if we had cos of t or sine of t. So here inside we have t minus 2 times pi over 6. Okay, so the way I look at it, okay, there's a formula in your book, but I don't remember these formulas very well personally. But what you can look at is, okay, so so we know that cosine has a period of 2 pi, right? So that function here will repeat itself. So if I have 0, okay, for t minus 2 times pi over 6, and eventually if this is all equal to 2 pi, it's going to give me the same cos value. So I could try to investigate which value of t will give me a 0 for the entire expression here, and which value of t will give me 2 pi for the entire expression. And the difference between those two t values will give me the period. So for instance, I'll show you what I mean by that. So t minus 2 times pi over 6, that's going to be 0 when what? When t is 2, clearly, right? The bracket needs to be 0, so t minus 2 needs to be 0, so t is 2. And when is it going to be 2 pi? So when it's 2 pi, it's going to be the same cosine value. So that occurs, well, here maybe I need to simplify this a little bit. So t minus 2 is going to be what? So I divide by pi, so I get 2, multiply by 6, 12. And then that means that t is 14. Okay? And now I look at 14 minus 2 is 12, so that's my period, because every times I add 12t, I'm adding 2 pi to the entire angle here in the inside the cosine. So the period, and that makes sense. This is what I had observed on the graph, because the period is 12, because there are 12 months in the year. So if I have a model with a period of, I don't know, 7, that's weird, because I would have like different values for January from one year and the second year, and then, I mean, this should be the same average. So 12 months. Okay. Or, okay, so this is how I would do it, because it involves no formula. There's a formula in your book, okay? So this is using a formula, but problem with formulas is that you have to remember them, and probably 2 weeks after the test is over, you're going to forget that formula, and then, well, you're going to be stuck again next time you see this. So using a formula, what's the formula? So if we have cos of b times x minus c over b, okay, then the period, so if y is this, then the period, maybe this is like if this, then the period is 2 pi divided by absolute value of b. So here the period would be 2 pi, and what's b here? B is the thing that multiplies t minus 2, so it's pi over 6. So that's 12. Or, well, maybe I went too fast here. This is 2 pi times 6 over pi, so it's 12 months. Anyway, I don't like formulas, as you can see, so I prefer much better to have an approach like this, which involves no formulas at all. Okay. Second question. Maybe this is one you can try to answer by yourself. When I'm looking for probably the month, right? When does the temperature maximal, largest as possible? So if I plan a trip to that city, when should I go if I'm like warm temperatures? Try to think about that and give me the answer. So we're maximizing, right? We've got t equals, let's rewrite it. T equals this, right? 3.75 cos of t minus 2 times pi over 6 plus 14.05. And we want to find the max of that. Okay. Probably, right? Probably for t in the background, like, although we're not going to take that into consideration right now, but t between 1 and 12, because it's going to be one of the months of the year. So if we have infinitely many answers, we're only going to give like one of them, because like it's probably going to be the same month, like, but from different years. Okay, so this is where you have to remind yourself that what's cosine like? Cosine is always, like, no matter what, cosine of whatever, right? It's always between minus 1 and 1. Because the cosine corresponds to the x-coordinate of the angle. So the x-coordinate is maximum right there, and it's minimal right there. So it's going to be, the max will occur at an angle of 0 or 2 pi or minus 2 pi, okay? So, so this occurs when theta, so the angle, which is t minus 2 times pi over 6, is 0 plus 2k pi. Okay, because it could be 0, 2 pi, minus 2 pi, 4 pi, minus 4 pi. So I've got many possible answers here, right? So there's 0, but there's 2 pi, 4 pi, 6 pi, and so on, okay? So I have an equation here that I solve for t to get all the possible solutions. So t minus 2 is going to be pi over 6 times 2k pi. Sorry, not times. I have to divide by pi over 6. So multiply by 6 over pi. So this is what? This is 12k. So overall, t will be 2 plus 12k, where k is an integer. And that makes sense, right? That means 2 will be, t will be 2, so I'm not going to look at negative values of t. That would be like looking back in the past. So it'd be 2, 14, 26, and so on. Okay, but those are all the same months. It's basically the month of February. So it's maximal in February when t is 2. So technically we could say, you know, t is 1 is January, t is 2 is February. Well, February covers from here to here. So t equals 2 is like mid-February, and t equals 1 is mid-January. Okay, so we could always write like mid-February. Okay. So next question for you. I'd like to know when the average temperature is 15 Celsius. Okay, so again, try to answer that question. Pause and come back. So, what do I want to solve here? I want to solve 15 is equal to my temperature function. Okay. So what I need to do is subtract 14.05 on the other side, divide by 3.75. If I do this, I will get 0.253 repeated is the cosine. So in other words, I'm just solving for a cosine. Okay. Now, let's look at the trig circle. So there are two places where the cosine is 0.253 repeated. Like, so cosine 0.253, so this is 1, right? So the cosine is the x coordinate, so it would be somewhere here. So that's a possible angle. But there's also this one, okay, with this point. These 2 points have the same x coordinate, so this would be 0.253 repeated and something else. Okay, so there are two angles. There's this one and this one. So if I take the arc cosine, okay, so t minus 2 times pi over 6, that's like my angle, theta, okay? Okay, so theta could be the arc cosine, okay? But that's going to give me an angle between 0 and pi. I can check, okay? If you want to, what's the arc cosine of that? Let's calculate this. So you get roughly 1.31 radians, okay? So I'm in radians here. I'm clearly getting this angle here. Okay, 1 radian is 57 degrees, so it's a little bit more than 57 degrees. And if I want the other angle, okay, well, it's basically by symmetry, it's going to be 2 pi minus the angle I just found. So the other angle, so that's the other possibility here, t minus 2 pi over 6 could be the arc cos of, the 2 pi minus the arc cosine. So 2 pi minus the angle I just found. Okay, so that's going to give me roughly 4.9099. Actually, it's not. It's 4.9098. Okay, radians. Okay, now remember, they're infinite meaning angle here, so this is plus 2k pi. Plus 2k pi. So now I'm going to solve each of these equations for t to recover when my max is. So from the first one, I get that t is going to be, okay, so t will be what? So I need to multiply by 6 over pi, so maybe I'll start with that. So t minus 2 will be 6 over pi times 1.31 plus 2k pi. So this is, again, approximately. And here t minus 2 will be approximately 6 over pi times 4.98 plus 2k pi. And then finally, solving for t, t will be 2 plus, okay, 6 over pi times 1.31. So I've calculated it. This is 2.5 roughly. And if I multiply 6 over pi by this, I get plus 12k. Or t is 2 plus 9.5 roughly plus 12k again. Okay, and then adding that, so t is 4.5 roughly. So I should put approximately here, plus 12k. Plus 12k makes sense, right? Because whatever max I find, if I add 12 to t, it's gonna give me another maximum. And here I get 11.5 plus 12k. So this one here, so remember, right, t equals 1 is January, or probably like mid-January, and then from 1.5 to 2.5, you get February, and then from 2.5 to 3.5 you get March, and then from 4 to 4. From 2.5 to 4.5 you get April. So 4.5 is like the end of April, beginning of May. So I'm just going to write end of April. And 11.5, well, 11 is November, so that's the end of November. So this is when the temperature is the warmest. So that kind of tells you that this is a city that's in the southern hemisphere. Actually, this is a problem that I took from the web. It was actually modeling the temperature in Wellington, and I'm guessing Wellington, New Zealand. Okay, so the temperature is the highest. The temperature is the highest at the end of April or at the end of November. So if you're planning a trip, this is when you should go, if you like warm temperatures.